Cool. I guess we can start by just quickly recap what we talked about last week. So we were basically exploring data types. So a bunch. But anyway, what you will be using are mostly we will really explore most of them. We talk a little bit more about char, like character, last week. But pretty much everything else you should have already seen somewhere. String, array, that's something we will talk about today. And hopefully we'll get to object, and that will be the main part of homework 3, and that should be the most tricky part of the whole processing part. There will be something trickier, but that's usually the first thing that, when you are learning about programming, and whenever you go into class and objects, a lot of, your mindset of how programming work will slightly change. And that's essentially what object-oriented programming is about. We talk about data type conversion. There's a sort of like a chain, like a hierarchy. But pretty much it's just like the smaller it is, the less expressive it is. So when you go from, a lower thing to higher precision one, they should be pretty much lossless. And then you can even extend that to floating points. But there's some details about that. Potentially it could be lossy. But for most of the case, if you are not, doing, I don't know, scientific simulation or something very requiring very high precision, most of them are used, more than enough. And if you go from the other way, then there will be potentially lossy conversion. Cool. And we look at this, like the rainbow band, not essentially about data type, but we are looking at, color mode, HSV, hue, saturation, brightness. And if you set the hue as mouse, we talk about map function. So here is still the old slide, but you can do hue equal to, map. And then you go from mouse Y, and you want to go from, 0 height and map that to, 0 to 55. And so that's the map function is doing. That's the same as this thing. So basically you want to map a scale to another linear scale. So that's where you can use map. Anyway, you can use transparency. That's the 32 here. That's the alpha value. That will be HSB alpha or RGB alpha. So the alpha value will be transparency. Then you can create some of the cool effect where you can overlap and blend colors together. And sometimes it will be very cool. Also in homework 3, we will apply a fading effect that will have the original things that just gradually fade out. So how we can do that is actually we just, whenever, this frame is done, you apply a small alpha value, like a rectangle, over the whole screen. Then you could slowly fade out previous generated thing. We'll see. And we stop somewhere here where we talk about the 2 ways of looping. So I think it's important, even though it's not like it's not a thing. It's more like a typical way, and you will always encounter that there's just the 2 ways of looping things. So the first way you can do is that you go from I to 1, 0 to 12, J 0 to 12, so that you get a grid. But the other way is that you can use percent sign and modulo divide sign, slash sign to convert a 1D sequence into 2D matrix. This will become important because when we are working with image, in processing, image is a 1D vector rather than a 2D array. So that will become an issue when we look at images. Anyway, so this is what we were talking about. So what we want to do is from characters 0 to 144, you go from 0 to 12, and then 13 to 24, 35 to 36. Whatever, and you keep going on. So that will be looping over the X index and Y index. So now your combining I index and Y index, X index and Y index, that will be I and J, so that you get that formula. So I plus 12 times J, so that you get the character code. And the other way, you can do it with by going from 0, the first code 0, 1, 2, 3, 4, 5, all the way to 144. But now you want to get where the corresponding I and J value will be. So where exactly that is in the X and J number. So when you do the remainder, you will get where you are at the X points. So, this will be everything divided by 12, perfectly divided by 12. This will be if you divide by 12 and you get remainder 1, remainder 2, remainder 3, remainder 4. And for the y-axis, you just divide it by that. So that's a typical way. So whenever you see something like a pair of percent, that modular operator, and the division operator, like the slash sign, usually they are converting a 1D thing into 2D thing. So what you want to do is, you have a 1D array. Later, when we are working with image, it's the same. So think about an image of, I don't know, like 30 times 30 size image, that will be 900 thing. Then in processing, it will be stored as 0, 1, all the way to 900. And the way how you turn it into a matrix is that, well, you grab the first 30 things, and then the next 30 value, you will move it to here. And then the next 30, you will move it here. So you are actually stacking or just rearranging, reshaping the 1D array into a 2D array. And so that's essentially what you will need. Cool. You will see some example likely in the homework or in future case. And then we want to talk about rendering text. You probably already messed with it in homework 1, and as you can feel from homework 1 is that text rendering is a little bit tricky in processing. The whole reason is that you need to understand how fonts work. For processing, it only knows that, well, we have some numbers. So H corresponds to a number, but how do we render that H into different fonts? So it's a little bit tricky. And that's why when you compute the size of that, it's, always a mess. But anyway, rendering text is just, text, str, xy, you likely know how to work on it. And we also look at, text align, center. So I guess that's it. I will just have it on the slide. Text alignment, right, center, left, so that you can do the horizontal alignment. If you want to do vertical alignment, you just need to get the second part of the text align. So you have top, center, bottom, and that actually is not like, it's like top align, but think about it, it's more like, well, we will have the top of my text to reach the baseline. So this will be the baseline. So we will use that as top align. So we will put our top, the anchor point at the top of the text box. We put our anchor point at the bottom of the text box. Cool. So that's pretty much it for data types and, a little bit about text alignment, text rendering. So that the rest, we will talk about arrays, and hopefully we'll get into objects that we need for homework 3. So arrays. So think about, in processing pretty much for now, we didn't actually want to, store a lot of numbers, and that's what array is for. So arrays is like something to hold a fixed number of items of the same type in many of them. So, I guess example is much easier. So look at this like integer x, and there's like this square bracket. It's a little bit tricky on the syntax at the beginning, but basically you need this exact syntax. So integer x square bracket. So square bracket basically means that it's array. It's holding multiple things rather than just one number. And you need a new integer 10. So now still this array square bracket, So now what we essentially do for this is that now we create an array of 10 buckets of 10 buckets for storing some integer. So once you're done with this, it will create 10 bucket on your machine where you know this thing is called X. So now X is not just one number. Now X is an array of memory space where you can store an integer. And so what's going on here, like X square bracket 0 equal 1, then now everything at the beginning will be initialized to 0. I'm not quite sure, but likely will be initialized to 0. But in this case, it's not initialized. Now you will be x0 equal 1. So basically now you can store the number into 1. So you can also do x3 as 2. Then now this will be index 1, index 2, index 2, index 3. So this will be index 3. So now you get a 2 here. So pretty much, very straightforward. You can just use number to work with an array. And there are so many different ways to work with array, how you started with it. So the thing that we talk about here is that, you have float, you define the data type of the array, and you show that this is an array, rather than without this, there's no way that processing knows that position will be an array. So with this, now it knows it's an array rather than a number, just a number. And you have this new, so that the machine knows that you're telling your computer to get a new chunk of memory that need to be able to store 3 float. And so you have float, square bracket 3. So that's the typical way how we do it. And this way, the numbers won't be initialized. But you can also initialize it at the same time. So what you can do is the things float square bracket position equal new float square bracket, nothing inside it. And now you have this like curly bracket, and you have the numbers inside it. So this thing is very tricky to write. So typically one thing you can do is like this. So basically now you use curly bracket to start it. And so this will automatically determine the number of the size of this array, because you only initialize with 3 numbers. So this is equivalent to you have this, and then you start with the 0, 1 with the 0 index 1 with 100, the first one with 200, the third one with 300. So they are sort of equivalent. So depending on how you are going to work on it. But I guess I would just go with it. Array is pretty straightforward. Most of the time you just need to get familiar with the syntax rather than it's very tricky. So you can start with like initializing an array where float square bracket again, your variable name, and then equal new, and then the same things again. Now you say how many buckets you need. So in the setup part, you can sort of initialize those. Position 0 will be 100. The second one will be 200. The third one will be 300. And now when you are drawing, one thing you can do is that you can actually use a for loop to do it. So when you get this position, now it's no longer just a variable, it's an array. So you can do dot length to get the length of that. So this integer I equals 0, blah, 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 it will just go over the whole, the 3 things again and again. And now you get the X position, you use this position as the X, then, you get that 3 circles. Cool. So what happened here? So what if we do this? If we don't do the initialization? Guess? I sort of hinted. Basically will be just initialized to O0. So that's actually very friendly for processes. Some of the other programming language, if you forgot to initialize it, it will just throw an error. But anyway, if you forgot to initialize the number, or you intended to don't initialize it, it will be default to 0. So everything will be 0 if you don't specify the numbers of that. How about this? So you have a float, pause, and without anything else, then this becomes an issue. Because for the model, why this doesn't work is that the model now only knows that, well, position is an array, but I have no idea how much memory we need to reserve for this thing. So the whole thing about new flow 3 is that, well, now we are actually reserving 3 memory slots for this variable, this array. But for this case, there's no way you know what it is. And now you are thinking about the length, but the machine has no idea what it is. So you actually get a new pointer exception here. But also here, when you are doing position.length, you will also get some error. There's also a very elegant way to go through the items inside of an array. So as we say, there's another way to define an array. So float square bracket position equal the curly bracket. So now you're 100, 200, 300. So this is much easier than this. They are sort of equivalent. You do this and then you do 100, 200, 300. But why, if this is the case, you will initialize it anyway, then why shouldn't we just do this? So this is much neat. So you can just do it. So what you can do here now is like float x column position. So this will basically, this is what we call for each loop. So it's a very nice way to just go over all the sample inside it. So this will basically have x equal 100, 200, 300. So this is sort of like in Python is like for every x in position. So that's a very clean way to go over each of the items inside an array. So for each loop, you just do float x column position and you get everything. But think about how you were going to do it with full loop, then it's a lot of stuff. You have to have an index, and then you have to check index is smaller than position.length, and then you go through the index one at a time. And they are equivalent, sort of. So, for each loop, you will see it again and again. I think in homework 3, I'm doing that. Who knows? Likely, we'll see. Cool. And so there are a bunch of stuff you can do with array. Should be kind of self-explained. Array.append, of course, it will append something. Expand is like you have multiple items to do it rather than just one. Shorten is like get rid of the last one. Concatenate, so you have like 2 array, you want to group them together. Subset is that, well, you have an array, you only want like say the 3rd one all the way to the 8th one. So you start somewhere and then you count how many you need. If you didn't give the count, then it will all the way to the end. So you are getting a subset of that. We can sort it, we can reverse it. So reverse will just turn it just reverse it, I mean. So all these functions will return a new array. That's a little bit tricky. For now, you might be wondering why we care, but later we will see why it's different, because later we will talk about list, and list has different behavior than an array. So all of these will return a new array, but for list, it will most likely be returning, modifying the same array. Cool. So we have concatenate and splice. I guess just something more. I guess we won't be using it much frequently, but concatenate is basically you just 10, 20, 30, 7, 80, 90, and you just put everything at the end. And splice is that you can insert it inside some position. So not a big deal. I don't think we will be using it anyway. You can also clone an array. So we have an array 1, 2, 3. So this is interesting because you are copying an array. So you have an array 1, 2, 3. Now here you have another array that you say ARR2 equal to ARR. So this array will be essentially the same as the first array. So that's the one of the tricky thing about array is that when you are copying an array, you didn't copy anything. So what happened here is that, well, we have an ARR. And what's happening, what we call a pointer, is that this ARR is not actually storing the value itself. This ARR is just a name, and you want to know where the name is. So this name actually points to somewhere on your computer. There's 3 buckets of integer where it's 1, 2, 3. So ARR will point to this thing. And now you are saying that, well, now we have another ARR2 that points to the same array that you have. So you have ARR2. Now, unfortunately, it's actually pointing to the same array. So now what's happening here when you do ARR0 equal 5, you are actually changing this value to 5. And that's why when you print ARR and ARR2, both of them are being modified. So sometimes you need to be very careful, especially when you are modifying array and list. All the time you will get some bugs. So just be careful of that. So if you do want to copy the array, you have to use ARR.clone. So that's different. So what happened with ARR.clone is that, well, originally you have ARR1 with 1, 2, 3. If you do ARR.clone, that meaning that it will be creating a new array automatically with the same, content somewhere else on your laptop. And now your ARR2 will point to that array. And so what happened after you do this, you change the first value to 5. You only affected the newly created array. So the first array won't be affected. So sometimes, you get some just undiscoverable bug. Sometimes it could be this. So just be careful about array. When you are doing this, be ultra careful that you are potentially just referring to the same array rather than actually copying the array. Cool. So those are some of the details. Whenever you're working with these arrays, lists, things will be more complex. Most of the time is that you just write your code and you forgot about all these details. Having these details is to remind you whenever you are doing something about, modification of the getting a new pointer, getting a new array, copying a real array, modifying stuff in the array, then you should be ultra careful whether you are affecting something else that you don't want to affect. Cool. Questions so far? I hope not. And yeah, I think these things are, when you started working with them, you will feel the pain. So likely we just have this information on slides and I'll quickly go over it. Once you work on those, you will get to know, some of the details. So string and characters are friends actually. So in homework 1, we have the string. String are basically an array of character, most likely. So string can actually do all the same stuff that arrays can do. So in homework 1, we pretty much have that string, right? We say string equal to, double quotes, hello world, this is Herman, things like that. So the easiest way to see what's a string, so character will be single quote, and and string will be double quote. That's a tiny nuance, but basically, string and quote, a string and character is just string is just mostly like an array of characters. So you can do concatenate, you can do splice, you can do shorten, you can do subset, you can go at all sort of thing that you can apply to an array. Cool. And the last thing I want to show is just debugging. Even though I don't use it most of the time, but it's good to know you can do that. Maybe I will show you later when we have an example. But there's a debugger that you can use. That's the butterfly at the right top. So sometimes, yeah, So what you would do this, you will have a console where you can show the hello world. So you can use print or print line. So print won't change the new line. Print line will change the line. So it depends. So this is like print line. So it will be hello world. I think I can just show some example. So this is especially useful when you are doing debugging. So you can say, use your for loop X, Y, and mouse X, mouse Y. Sometimes you forgot, say what this array is about. So you can just print that array, especially in the for loop. Then you can see what's the actual number. Are you doing the right computation? So it's very useful to do debugging. So you can do print. If I just do print, keep print, I don't know, A, then you will see a hey here. And now if you, oops, you do the hey again. So now you get hey, hey. So if you are doing print, it won't print a new line. So everything will be, stick together. So if you want to have that easier to look at, you can just use print ln. So it will add the new line at the end. So print ln is actually equivalent to print a, and at the end, as we talk about in homework 1, where you have do this \n, then it will print the new line. So these two are actually equivalent. So print ln is basically appending a new line at the end of what you are going to print. Cool. And so this is the debugger. So you can click the butterfly and now you run it. And you can do step-by-step moving. For now, I think what we have here is just too simple. So it doesn't have like step-by-step things. But you can also see all the variable that you have here. Say if we want to draw a circle, X, Y, 20. Then when I start the debug mode, when I start, oops, let me write it. The whole thing. Always set up. Size 400 for 400. Oh. So you can actually start at the debug mode. And then once you click the debug mode, you will see this variable thing. And when you start it, it should go over one step again, but somehow it's not showing here. It says debugger busy. I don't know what happened, but usually, mouse X, mouse Y, the value will be show up here so that you can, easily debug stuff. I can show you what it will look like when you do it correctly. I don't really use the debugger, so that's why it's a bit shaky. So, you click the butterfly to set up the debugging mode. And now you have the debugging mode on. So now you can just, step one step further, continue. And you can also see that, that's variable inspector. You can see all the numbers. You will have width, height, mouse X, mouse Y, everything you can see. So it's very useful when you want to do some debugging, but you can also just use print to show those. Cool. And we didn't get into this, but likely in homework 1, homework 2, you will see I use some line comments to write stuff. So you can basically write whatever. You have the documentation at the top. You write something about the code and write something about the function, write something about everything you are doing. So that's for you, but also for whatever whoever using your code so that they know what you're doing. Cool. So line comments, block comments. Line comments is 2/, block comments is /*, and then you can write a lot of whatever stuff, and then you close it with a star slash. Cool. So that's it for this module. We talk about how you can start and define an array. So this is the way how you do it. Typically, you declare and then you think about its value later. And the syntax is a little bit tricky. But that's it. Float, you want that square brackets so that it knows that it's an array. And then you have your typical variable name. Now you need new, and then you want the same things here. Now you specify the number of items that you want. And you can also do this much neater way to do it. If you know the value of those, you just use curly bracket with all the numbers that you have. Cool. And good. Now we are jumping into objects. That's the big chunk of the whole class about processing. Good. Hopefully we will get to this at the end. So that sort of show you why we need objects, because each of these ball will have their own things going on. Pretty much this ball needs to know where they are, but at the same time, when it hit the ball, it has its own behavior. So object is a way to sort of like combine those things together. Function redo things again and again. A variable store a number to remember it, but object is something together. You want to know where the ball is, but at the same time, the ball will do some function. So we combine them between an object. Cool. Let's get started. Cool. So objects. So what is an object? So as I said, variables store data. Functions provide functionality. An object is basically a combination of that. You want to store data, but at the same time, you want to provide functionality. So this is like the most, simplest thing I could imagine. So bouncing ball. So think about this is like, this will be our first class. I mean, class is these things. And when you initialize something of this class ball, then you get an object that's a ball. So class ball, you will start with like float xy, float size, float speed x, float speed y. So these are the what we call fields, but you can think about fields are just variables of that class. So to define a ball, you want to know where it is, how big it is, and what's the speed for it for now. And that's all we need. And then we will have a constructor that basically shows that, well, now we want to initialize the ball. What do we need? We will get into that later. But this is basically help us to know how we actually initialize the ball. What do we need? Do we need to know its x and y? Do we need to know its size? Do we need to initialize the speed x or speed y? Or do you want to have everything just randomly, generated? And these are different functions that you can use with this ball. So one, you can show the ball. So if you do ball.show, you will show the ball. If you do ball.move, you could move the ball. You could also do check walls so that you know that whenever it touches the wall, it will change the direction. And all these things are just functions that your class can do. And we call it methods. So fields, constructor, methods. Basically, you can think about these are variable. Let's define how you can, initialize an object. These are the functions that you can use within that object. So now we will get a specific example. So what we can do here is that now we are writing a class. So whenever you are writing a class, you want to, a new tab. So now you define this class ball. So now, click at this arrow thing here and then do new tab. And then you usually name that file with the class that you have. So now we are defining this class ball. So we will have a new tab that's ball. So now you have the ball here. So say, let's just copy this class ball. And we have a bunch of value, x, y, size. This will be the ball size, speed x, speed y. Cool. And now we want to have the constructor. So for now, we do the simplest form, where we don't get any number of that as the input. So we just basically define what we have. So for every ball, we assume that they started in the middle. We have a bunch of the same place, y equal 20, size equal 10. And then we have speed x equal 3, and then speed y equal 3. Cool. So that's basically our ball function. And so what you can do now is that now I've defined this ball class. Then what you can do here is that now we can actually start it using a class. So think about a class as like a predefined sketch that you can use that defines some template of an object that you can use by default. Cool. So we can do a bunch of stuff. So think about this ball, what we want to do with this ball. We could say something like we want to show the ball. I think this is the easiest way that we can start it with. So whenever we call this show, we will just plot the circle. So the circle will be x, y. So this will be this specifically ball where it is. So x, y, and size. So this will be the method that we can call for that ball. Cool. Let's just skip all the complexity here. And so this is the way how you can start it using a ball class. So what you would do is that now think about, you have a float. So when you're defining a variable, you say float x equal 1, right? So the whole thing is about, well, this is the data type. And this is the name. And this is the value. So that's all you need to define a variable. So now here, basically what's going on, ball. So the first one will be data type. So now we are creating a new data type. That's the thing that I define here. That's a class. And now we have a new variable that's width of this data type. So as usual, we just set up a 400 by 400 canvas. And now we have to initialize this ball. So similar to how we started an array, we would just do new and then ball class and then this parenthesis. Cool. So what we can do now, then, background 50. And then we can just do ball dot show. That's the only thing we define. So this ball function of class pretty much does nothing. It's just, it has a bunch of fields that you can have x, y, size, speed x, speed y. It would just have them as a specific numbers. It doesn't allow you to change it. But this is the first thing we started with. And then when you call ball.show, it will just code this function and show it as it is. Cool. So when you, when you run this file, run this sketch, you get this. So now the way how we get this bouncing ball is that, well, now we start making it move. So we can do, a different function where now how do we move the ball? So let's think about move. So, in the previous, in homework 2, likely what you are doing with move is that, just x plus speed x, right? So now x become x plus speed x. That's how you move a ball most of the time, at least in homework 1. And the same for y plus equals speed y. So now y become y plus speed y every time. So now you have another method that you can do. So this will move the ball according to the current speed. And this will, this will show the ball. Cool. So now what we can do is that before we show the ball at each frame, we can move it. So now you see that, it's gone. So you have a ball and you move it and then you show it. So this is sort of like the first thing we try, like never ending ball that will just move and then gone. So we need to add all the check wall stuff. So this is what we have. So this is likely just the homework too. Basically what you want to do in homework too. So we want to have this like ball check walls. So we want to check whether it has hit the wall before you move it. So if it hit the wall, then you want to change its direction. This should be camel space. Cool. So how do we check the ball? Check walls. So what we'll need is that if x larger than the width, so it hit the y right hand side, or it is smaller than 0, then you want to change the speed. So now speed x will become minus speed x. So that's basically changing the direction of speed x. Whenever x larger than width, if x is outside, change that speed. When x is lower than 0, you change its speed because you hit the left wall. So that's essentially what you need. Okay. So now pretty much the same. You apply to y. If y larger than height, meaning that it reached the bottom wall. If y smaller than 0, hit the higher wall, top wall, then you change the speed. For now, you see that it just stuck at the diagonal because speed x is equal to speed y as 3. So it will just stuck there. But if I change it a little bit, then it will start bouncing around. So pretty much this is like the first class that we can do. So what does this ball class do? Well, it doesn't allow any customization. All of the numbers fields are predetermined because we don't do anything about the constructor. We will talk about this later. But it has 3 methods. First, you can show where it is. You can move it, basically x plus equals speed x, y plus equals speed y. And then you check the walls. Whenever you hit the walls, speed x will be minus speed x. You change the direction, same for speed y. So what we are doing here is that ball check walls. If it hit a wall, you change the speed, and then you move it, and then you show it. So this basically just turned what we have previously become something else. And so now we can actually just have 2 balls at the same time. So now it become much fun and much easier to define a new ball. You don't need to write everything again. Cool. So you can pretty much copy paste and then you add another ball. And now you will see the problem of that is that, well, it's still 1 ball because these 2 balls have the exact same speed x, speed y than the initial point. So now becomes the main part of constructor. Cool. So just to recap again, you have declaration where you have ball. So you have a ball variable with lowercase b, which has the data type of capital B. And then you initialize, and then now you use it with the methods. Cool. And as I said, you usually define your class at a separate tab where the name is just the class name. Cool. So we just see this. So now you can actually do a fancier constructor. So in our example, where our constructor is predefined, so this doesn't allow any, customization. So one thing you probably notice in where you can do circle like 200, 210, that means that, these things should be able to be customized. So how do you customize those? Usually we will just, the simplest way, we just customize everything. Float X, float Y, float size, float speed X, float speed Y. So now we have all of these things, and there's a tricky part of that is that you need to use this dot X equal X. This is slightly complex, but I will get into that later. So this dot X equal X, this dot Y equal Y, this dot size equal size, this dot speed X equal speed X. Cool. So once we've done this, well, sounded fine. Cool. So what we can do now is that now our constructor become a different constructor. Now you can take inputs. So it's no longer something that will just predetermine everything for you. Now you can actually set it up. So say we want to have a ball that start in the middle, 200, 200, the size 10, and it will go right and bottom, just as usual, 3 and 2 speed. But now we want to have another ball that started at 100, 100, and it's slightly bigger, 220 size. And it go to the left top, so -4, -2. Cool. So now if you do it, then you see that, well, these two balls started at a different place. Let's do it again. So look at, this one started at 100, 100 and go toward a specific direction, and the other ball will go to another direction. So now you can imagine, with this class, you can actually you don't need to redo all the ball thing. You can just, define a new data type, and it has a bunch of functions that you can use. And so that, you can create a bunch of balls easily. So a little bit about this dot X equal X thing. So all the complexity here is that, there are two. So you originally defined this X, flow X, Y, size, speed X, speed Y. And now in this function part, you also have this X, Y, size, blah, blah, blah. So there are two X here. So this X will be this X, and this dot X will be the outside X. So you are grabbing the, the input X, and then you store it to the function X. So this is actually equivalent to, you can just rename this thing as XX, and then YY. Then you can just do X equal XX and Y equal YY. So the this dot X equal X is whenever you have two things that's sharing the same name, then you want to use these. If you can just rename them as a specific non-colliding variable, what you want to do is just to store this XX to the field. So that's why sometimes it look like this dot X. So you want to grab something you get from the constructor input, you want to store it to my specific field. So this dot X will get the field variable. Cool. And you can do all sort of thing. So you don't necessarily need to, always customize every single value, X, Y, size, speed X, speed Y. Sometimes you just have it be random. So, think about this constructor. Rather than, specify everything, you could just do X equal random width at the random position, random Y position, random speed X, and random speed Y. So you can do all sort of things to customize your class. Shall we do this? I guess we will use it later, so probably download it. I think I have the link somewhere. So you can download this class. this. So you can find the example class here. So hermandong.com, teaching pad 240 50404 2025. That's basically our class website. And then at the final slash, you do capital BALL.pde, then you will find this file. Anyway, that's basically what we just go over. I think we'll just skip this. So basically, you know, now you can create 2 bouncing balls. You can create more than 2 bouncing balls, actually. Cool. So what you will do is just, you know, ball, new ball, ball 2, new ball, and then you just do the same thing. But now there are 2 balls. Cool. And actually you can now get the thing that we just talked about. You know, we know how we can do array. So you can actually start a new array of balls. So capital BALL, this is the data type. You know, get the square bracket so that it knows that it's an array. And the array is balls. You get an S bro. And new ball 20. So now you have 20 buckets of balls. Doesn't feel like 20 balls. I think it's 10. So anyway, this example is not the same. So this will be just 10 balls. Anyway, so you can also do for loop. So for each of the ball, you want to have each bucket, you will have a new ball. And this is assuming that we are automatically getting the x-axis and y-axis, x position, y position, and the random speed. So everything will be randomized. Assuming that's the ball class that we have. And then, you know, for each of the ball at every single second frame, we will just move, check whether we hit the wall, and then we show it. You like it? Do you think there's any question on this? We will get to that, I mean, because sometimes it will overlap. It doesn't feel right. So later in the case, we will see we can actually apply some collision detection, and things will be very, very tricky because, you know, think about check walls. Now you want to check whether you hit another ball. So there will be extra complexity. But now we are getting close to that. So for now, it's a bunch of ball that doesn't care about another. When they hit them, they just pass through it. But at least now you can get a bunch of balls. Cool. So this will be sort of close enough to homework 3, I guess. Not there yet, but almost. Yeah. Questions so far? Nope. Cool. Yeah. And there's also this thing called signature polymorphism. So that means that when you are working with do you have any example? Do we have any example of I think we have. Oh yeah, say random. So think about, you know, say random 1. You'll get a random number between 0 to 1. And you will also have another function you can call random with 2 inputs. So you might wonder why we can have so many different ways to code this function. So this is a function, but you have different ways to code it. You can give it a number. It will be the, you know, the upper bound. And the lower bound will be 0. But now if you code the 2 thing, now the first one somehow become lower bound. So that's what we call the signature polymorphism. So signature is like the name and the parameters that you need. That's what we call signature. So now you can see that you can actually define 2 different signature for the constructor. So sometimes if you don't care, you want everything to be randomized. So in this case, that's not what we want. We want everything to start it in the middle. Let's have it running. So, you know, we want everything to start with the middle and then it explode. So think about, you want to make a firework animation, then this is the case what you need. So to do that, you want to be able to specify the X and Y position where it starts. So now you can have another constructor where you have ball flow X, flow Y, where you set up the X and Y, but everything else will be randomized. So you could have multiple different constructor with certain, parameters or fields predefined and other to be randomized or everything to be randomized or everything predefined. So you can have multiple different signatures. Cool. So I guess object is something that you might be wondering why we should write something this ugly. But over the time you'll feel its benefits. So this is just to show it some of the benefits, organization, naturally organized into files or blocks. So each of the class will be a file. And later on, we will see a lot of library when we are doing, sound analysis, doing all sort of like stuff like that. When you are using external library, you are basically grabbing a bunch of class predefined. Reusability, so similar to function, now a written class can be reused in many projects. So later on, we will see FFT, P image, P vector. These are just different objects predefined in some library on in processing. So you can reuse it again and again. Ease of maintenance, this is what we call in software engineering that each single object will have their standalone part of it so that you can work on this class and object. And the goal is that, we want to define an interface rather than exposing everything. So think about there are two teams, one working on the front end, one working on the back end. What you get on the front end is that what will be rendered in the front end for back end folks. For front end folks that were wondering, what things that we should be able to interact and what are the data that we should correct. So you only talk about those, interface without understanding what's going on inside it. That will have ease of maintenance, but also ease of communication. Abstraction and encapsulation. So if there is something about FFT, do we really need to know what FFT is doing? Fourier transform. So most of the time, we don't really need to know. We just want to know how to use it. So most of the time, object is a good way that you define the interface. Say, the ball, this example where you show the ball, and do we really know how to move the ball? Even though internally it's just X plus speed X, Y plus speed Y. But if you show something like this, people have to think about what does that mean. But this, the actual meaning of these are just ball that move and, ball that check walls rather than, ODC files. So it defines the interface, how you interact with that object rather than, the exact implementation of that. Cool. So some example classes. Actually, fun fact, not fun fact, I mean, processing sketch itself is an object in Java. So the whole processing template, the whole processing sketch that you're running is actually a P applet object in Java. But sadly, you cannot directly access that in processing unless you want to embed in processing a JavaScript, Java program, not JavaScript. So you can also see this is the how they show how the whole processing language is developed. So you can see that it actually initializes a p-applet object and you run the setup thing. That's what now you sort of see what's going on behind processing. So you have that voice setup thing, right? So that will be called after you initialize the p-applet, and then you will start the screen, the rendering like GPU or whatever, the display, and then you will stop painting it. And the draw function will just keep repeating until you get a stop signal, and then you destroy everything. So this is actually the whole processing is being implemented in Java, and pretty much most of the time we are using these two things. Cool. P vector class is a very cool thing. So now you can actually get a vector. So what we can do here is that p vector is a predefined class in processing. You don't need to import any library. So you can do POS, new p vector 200, 200. So what it will get, a vector by definition, is it's point to somewhere. So now 200, 200 is actually not point top. It's actually point this way. So it will be very bad. So it will be a 200 by 200, vector. And you can actually just use position dot x dot y to get the x and y value. So this is very helpful when working with rotation, when working with a bunch of things. We will just show an example to show you what's going on. So you have a vector that's 100, 0. So you will get basically a line. So you have the origin somewhere, and you define a vector that's 100, 0. So this is your initial vector. So this is your p vector vect. And so now you can do vec.rotate pi times 0.01. So what it will do is that, now that's the benefit. That's the beauty of vector object, is that, previously we talked about the sine, cosine stuff that you don't care. I just wanted to rotate. I don't really care what about those like cosine and sine. So now we just call this function. It's predefined. It's called, vector rotate. So now it would just turn this vector into some value. I don't care. I don't really care, right? Because we just need to know that vector has turned first small angle. And exactly where? I don't really know, but I would just use vector x dot x and vector dot y. So this point would now be vector dot x, vector dot y. I don't really know what that number is, but anyway, that's the beauty of object. And then we add 200 and 200. Now it becomes somewhere here, and then we point to that position, and then we draw a circle over that. So, this is sort of one of the benefits of having a predefined class. And the beauty of that is that now we don't really need to know what's going on within this. That's the class designer need to think about. And we are using it rather than, going into all the details of how it works. I guess we will also skip this. But you can also rewrite these things with p vector. I think we just need to hurry it up so that we have homework ready. But this is the way how you write out the things, flow x, y, random, and then speed x, y. You have to randomize that. You can actually use a p vector to do that. So your p vector position, new p vector, now p position x, y. It could be two things. So x, y is always sort of like coupled in some sense. So you could also use a vector to store them. And for the velocity, you could also do that. The velocity x will be c times cosine, y would be speed times sine. But this doesn't also, doesn't really showcase the power for a p vector. So one thing we could do further is about this p vector static methods. I will just show you how it works. So you can actually do three very cool function, which is p vector dot random 2D. It will create a random 2D unit vector at a random direction. So what it will give you is a random direction. That's just this could be 0, 1. I don't know. Say this is, what's this? No, this is not 0, 1. This is 1, 0. And this is 0 minus 1. This will be 0, 1. And this would be, I don't know, square root 2, whatever. 0.7-ish, whatever. You get like different numbers. So you can actually get a random 2D, random 3D, and front angle. Let me show you that by this example. So what I'm showing here is that, your random Mycin randomly get in a different position. So this is sort of like what we are trying to do previously. So in homework 2, you want to get the random direction, right? When you restart, you want to shoot it somewhere else. And at that time, we are thinking about, well, we get a theta, and then we just do cosine and sine. But now with this p vector random 2D, it's much easier. You can just randomly get the 2D unit vector at a random direction. So this can be very easy to use. So what you would do is that p vector dot random 2D, you will get a random unit length vector, and then you times it by 100. Then you get the random vector with 100. And then you do 200 plus position dot x, 200 plus position dot y. So you start from here, you get a random vector at different direction. That's how you get this plot. Cool. I guess we pretty much go over that. So we will basically use those to do homework 3. So homework 3, we will be doing this solar system. So the first question, you don't necessarily need to use object. But now you want to, you could use p vector, you could just use x, y, but get a sense, how polar coordinate work. So I give you the template processing sketch with the sun and the earth. Now you want to add a moon that just circle around the earth. So think about it, how to do it. Shouldn't be too tricky. So now you want to basically have another variable that's rotating around the earth, and this origin will be at the earth. And the second one, now you need to use object. So each of these things, each of this planet will be an object. So you want to remember where they are, what's their speed, and then you want to show it, and then want to move it. So move it, meaning that you are turning it, you are rotating it. So it will be a different position, and showing it just like showing up. And also you will see that there's this like fading effect. That's also what the alpha value is very useful. So this is the processes sketch that you can start with. So as I said, for homework 1, you will start with this, with the template sketch. So this is what you'll get. And now you want to add the moon on top of it. This is this sketch that you have. And the fading effect is like this. So basically we will have no stroke, no border, and field 0, 100. So that will be the, so 0 will be the black, background, and 100 will be the alpha. So when you do just 2 numbers, so when you are doing color, you can do, as I say, RGBA, or you could just do a grayscale, grayscale. And if you only give 2 numbers, then that will be grayscale and alpha value. So this will be grayscale alpha value. So this is applying a black, but it's like with alpha value 100 on top of it every time with the whole shape 0, 0 height width. So you so once you start drawing something, you apply a transparent mask on top of it. So that actually gives you the fading effect, because the previous thing will become fainter and fainter over time. So this is a very handy way to create the fading effect. And so if you look at the moon, you will see there's some trace. There's a fading trace behind the moon and the earth. And that's the same for the this thing, because you see that, there's some trace behind the planet. And so for the second question, you are already provided this star class. And basically what you want to do is just to finish it. You need to define the constructor. Remember to have the signature correct. You have to define the parameter, what you need. You have these fields. What fields do you want to customize? Radius, speed, color, theta, x, y. What are the numbers that you need? And what will be your constructor? And how will you show that? Likely some circle-ish. How do you update the star position? So, you want to know where the theta, where the angle is. and then you compute where the X and Y is so that you can show it. So it depends, like how do you implement it? So that would be the key of homework 3. Questions? Oh, good. Look hard or too easy? Yeah, you'll get to experience class. There will likely some questions about class once you get started with it. It's always a mess. Yeah. Cool. So you were also given a template sketch. So I think this is more than enough for you to get started. So you already get I pretty much do everything for you. Yeah. You just need to extend that to multiple class. Yeah. Multiple instance. And you need to finish the class template. Cool. If no, I guess that's also sort of like the end of the object slides. So I guess again, object is just a thing that combine, functionality and variable at the same time. And especially after you work on homework 3, I think you will likely get why we need a class, because there's just literally no easy way you can handle a bunch of things that you need to store the state, the status, the variable, the fields of that thing. Cool. We start from this bouncing ball. This is simplest one, a constructor. Show the ball, show function, move the ball, check walls, check if the ball has hit the wall. If so, then you change the speed, the direction. So fields, constructor, a bunch of methods. That's what a class is for. See this class ball. And usually we use capitalize the first character for a class. And you can initialize a new ball, declaration, initialization, call the masters to work with it. So that's how you interact with the class. And you can extend it to 2 balls. So basically do the same thing again. So you can even just use arrays to do it even more. And signature polymorphism, not sure if you encounter that, but that's also why some of the function you could have different optional arguments or sometimes different ways to initialize a class. And, in this case, especially when you want to set the X and Y, then it's nice for everyone to start at the middle. So you may have a new constructor. Or, the other way is that where you just started with this, X, Y will be randomized, but, once you initialize it, you just override its X and Y position to create that effect. Multiple ways, but polymorphism sometimes is helpful in this case. Processing sketch is an object in Java. We won't be able to work on that unless you are trying hard to hack processing. But processing itself is also an object in Java. We talk about p-vector. There's a bunch of things, but I guess p-vector is mostly helpful when you are doing this random 2D thing. So that you can get a random direction. That's very handy, especially when you are working on all the bouncing balls stuff, where you want to, randomize the position and randomly throw that ball to a specific direction. Cool. So that's next week. Should be on Wednesday, we will talk about list and data IO. Shouldn't be too tricky, but you can pretty much like array. But we will get into that.